Hi, I'm Pel, and you are? This sem, we discussed 6 topics, and those topics are models of cost, revenue, and profit, introduction to probability, probability distribution, decision analysis, utility and game theory, and forecast. We're going to solve some problem using this book for each chapter. Ready? So using the given formula, we have b equals 800 minus 10p. We're going to substitute p with 20 as the price. So we're going to have 600. And then, using the same formula, we're going to substitute p with 70. And we're going to have 100. The mathematical model for the total revenue is the annual demand multiplied by the unit price. So, we're going to have 800p minus 10p squared. So, using the formula we had in part B, PR equals 800p minus 10p squared, we're going to substitute p with the price 30, 40, and 50. First with 30, we're going to have 15,000. Next, for the price 40, we're going to have 16,000. And last, for the price 50, we're going to have 15,000. The biggest is 16,000. So using the best price alternative 40, we're going to substitute it to the annual demand formula. So we're going to have demand of 400. First, we're going to copy the table and using the given numbers, for example, the yes, 750, we're going to divide it with the total number 920 to get the joint probability. So we're going to have it like this: 0.375, 0.085, 0.475, and 0.65. To sum it all, we're going to have 1.0. So the 35 and above bracket is better than 18 to 34 with 0.54 probability. So the probability of not having health insurance using the joint probability table, we have 0.15. So we're going to use the formula, the probability of 18 to 34 and no over probability of no. We have 0.085 over 0.46, so we have 0.1848. So for this, we have 35 and up and no over probability of no. So we have 0.065 over 0.54. The answer is 0.1204. We have probability of no and 18 to 34 over probability of 18 to 34. We have 0.085 over 0.15, 0.5667. There is 85% chance of probability that an individual in US is covered by health insurance and 15% of not having health insurance. So we have the mean as 20 seconds. We're going to use this formula, 1 minus e raised to x over mu. We have x as 10 and the mu as 20. So we have 0.3935. So we have 30 as x. We're going to use e raised to negative 30 over 20. We have 0.2231. First, we're going to solve using negative 30. We have 0.7769, and then using negative 10, we have 39.35. Subtract it, we have 0.3834. The decision is either to construct small plant or large plant. And the chance is the long run demand, whether it is low, medium, or high. So for the influence diagram, we have the plant size going to profit and the market demand affecting profit again. So we have the two decision alternatives, small and the large size, given with their chance event, the low, medium, and high. So we have maximum profit, minimum profit, and the maximum regret. For the optimistic approach, we have 500, plant large. For the conservative approach, we have 150, plant small. And for the minimax regret, we have plant large. We have player A and player B. A1, A2, and A3, B1, B2, B3. We're going to find the minimum of -1, -3, -4 for each row. And for the column, we have the maximum 5, 4, and 2. We have -1 as the maximum in the minimum side, and we have 2 as the minimum in the maximum side. Given that A2 is better than A3, we're going to eliminate A3. So now we have the 2x2 game. Using both the expected value of each strategies, we have -1, p plus 4 minus 4, p equals 2p minus 3 plus 3p. We have p at 0.70. And for strategy 2, we have 0.30. Then, using the expected value of both strategies, we're going to find Q. So we have Q equals 0.50. And for the strategy 3, we have 0.50 also. We add the first 3 percentage, 80 plus 82 plus 84, and divide it by 3, we have 82. 82 for the 4th month. Repeat the process for the next month. To compute for the error, we're going to subtract the forecast from the percentage given and square it. Add those square errors and get the average. We have 11.12. Now, we're going to use the exponential smoothing forecast with the alpha 2 or 0.2. Using your calculator, you have the alpha 0.2 times the given percentage 82 plus 1 minus alpha 0.2 times the forecast 80. We have 80.4. Find the difference between the given percentage and the forecast and square it. Sum it up, we have 39.06 divided by 12, we have the MSE 3.2055. Using 3-month moving averages, we have 11.12 over 9. 9 represents the 9 months. We have 1.24. When using the exponential smoothing forecast, we have 39.06 over 11. 11 for 11 months, we have 3.55. 1.24 is smaller and is the better forecast. Forecast for next month. Go back to the 3-month moving averages. You have 83 plus 84 plus 83 over 3. We have 83.3.